Let's start off today taking a quick tour of what you're going to see when you get into the Canvas shell for this class, or what you're going to see now that I've fixed some things in the Canvas shell. So this is the home page. This is where you're going to find out what any announcements are. So any new announcements will show up right at the top. You can check those out. So this would be a good place to go. If I suddenly have to cancel a class for whatever reason, this is where that announcement will be. I try to get into the email and send out a message to your email address, but sometimes if a class has to get canceled at the last minute, I don't get to make that email. So I just go with the announcements here. The announcements page currently only has the one announcement, but more announcements will show up. So the other major part of the homepage are the modules. So here are some of the modules that I fixed. I had broken them in the first place. So getting started with Wileyplus, this is one of the things I asked you to check out. These are just some links to some information about how to get through Wileyplus. How to succeed in this course is how to deal with taking an online course. So if you've done this in the past and you're really good at it, then just need to peruse that really fast. But there are some places to get some tips for working with Wileyplus. And then there's 2 assignments for giving you a little bit of practice about how Wileyplus works. That's going to be the main way we interact as far as the homework goes in this class. All the homework will be assigned through Wileyplus. If we scroll down a little bit, we'll see the first chapter, chapter 1, right triangle trigonometry. And I've cut out a bunch of the stuff and just gone with the homework. So if I click on the first homework, section 1.1, good place to start. It'll bring up the Wiley resources for this section. If you click on the first link, that's going to be the electronic textbook. So that'll open up in a new tab eventually. I think I'm asking my computer to just do way too much. There we go. So it'll open up to the appropriate section that you'll want to read. It's a math book, so I recognize when I say your homework is to read section 1.1. Math students interpret that as, I have no homework. But you can check out all the stuff that we talk about. We're going to talk about in class. And if you think I missed something, you can check it out in the e-textbook. In addition to that, there are preview videos and example videos. So you can check out the example video. Just click on play, and that'll bring up one of the examples. Then down in the big blue section is where you can open the homework assignment. This is where the problems are going to show up. So if you scroll down, you can click on open, and this will open the assignment. Now, I don't recommend this as a position for doing your homework. Apparently you got to levitate your computer, your laptop, like about a foot off the ground, and then sit on the floor. I recommend sitting at desk with the laptop on a table, but you do you. So you click on open, and that'll open the assignments, and then you'll want to click on start assignment to start doing the problems. In the overview, we have the assignment policies, the section that we're talking about, and all the policies that are in play. The important one is that you have unlimited attempts per question. I think the point of doing this is not to score points before anybody else, but to keep going until you get the right answer and understand what's going on. So that's why I switched to unlimited attempts. Some of you will get the solutions right away on the first attempt. Some of you will take 3 attempts. Some of you will take several. Switching over to the questions, you can see how many questions are on the assignment, and then you just start clicking on the questions to get to the questions. If you get the question wrong, so I'm just going to put, it will tell you that you're incorrect. And so you'll just keep going. Well, maybe it's negative. So notice that it says your answer is partially correct. So the negative part I got right. So if I read the question again, angle in degrees, 4/5 the rotation clockwise. We haven't gone over this, but clockwise is going to be negative angle measures. And then we just have to get the 4/5 correct. And then we can just keep trying things. I recommend not just randomly guessing. Like actually try to solve the problem, but you do you. So that's going to be your main interface with Wileyplus. Once you finish the homework section 1.1 homework, then you'll be able to go on to homework section 1.2. Other important locations on Canvas we're going to have to identify is the discussions. Discussions is where I'm going to put the recordings or links to the recordings and the notes. So once we write down notes, I'll scan those and I'll post them in the discussion. And so this will be a link to the notes. And then this Thursday down here will be a link to the meeting recording. For the most part, everything else is pretty self-explanatory. Grades, this is where you'll go and check your grades. Well, I only got a 0.5 out of 8 for section 1.1 homework, so I should probably go back and redo that. You can read the syllabus. I'm pretty sure if I put the answers to the final exam in the syllabus, no one would notice because it's a syllabus. And files is where you're going to find the notes. So if you can't see the link to the notes, this is the folder they're going to show up, in which they will show up. Any questions on the Canvas business?
Yeah, I have a question. Would you mind sharing your screen again to the 1.1?
Sure. Let's see, Google Chrome. Sure.
Yeah, I think it was back in modules.
The homework?
Section. Yeah, can you click on that one?
Yeah.
Under the first link, the 1.1 angles, degrees, and triangles. When you open that up, there's this little section that says 1.1, but then under that it says 1.1.1. Like, is the section that this link takes us to, we have to read the whole thing or just the piece in there?
You don't have to read the whole thing. You're going to read it like a math book, not like a book. So
like there's like 1.1 and then
so, yeah, 1.1 is broken down into 1.1 angles and degree measure. So there's the skill and then the concept. And then if you scroll down, there's a 1.1.2. Eventually, there it is. We're talking about triangles, and that's also part of section 1.1.
So the whole page, all the way to the bottom, is all 1.1.
Yeah.
So we'll
probably the best strategy for dealing with a math book. One of the best strategies is to just start doing the problems, and then when you get stuck on a problem, that's when you can go back and refer to what's going on in the textbook. That's usually the way to start dealing with math books. start doing problems, because maybe you know some stuff already. Maybe you can guess your way through it, and then when you get stuck, or if you're unsure about something, then you can go back and refer to a specific example in the book. That way you don't have to read the whole thing. That make sense?
Yeah, that made sense.
Right. So, and this is in the spirit of doing math anyway. Because the idea behind math is that you take a math class and you're trying to learn enough math so that you don't have to do all this math anymore. It's why it's really weird when teachers are like, I'll show all your work, but they don't mean your work. Show all the work that I decided you need to do. And so you have to write down every single step. But the point of the math class is to not write down every single step. The point of the math class is to become proficient enough and understand how things are going to go and see patterns so that you don't have to write down every single step. Does that make sense? And so reading the math book, we should practice that by just trying to do problems and only looking up the things that we need and using the problems to expose what we don't understand, and then go back and to the book and try to fill in the things that we don't understand. To me, that's the point of the math class. That's why when I say show your calculations, you need to show the calculations that you need to do, rather than the ones that I've decided you need to do, because I don't know what calculations you need to do. If I was to multiply 23 times 17, I would pretty much have to write that down. I'd have to start writing stuff down, because I can't keep track of 4 whole numbers all at once. But if you might be more proficient at arithmetic than I am, in which case you're just like 23 times 17 is 391. And you don't need to write anything down. Make sense?
Yeah.
It'll become more clear as we go further. All right, so we talked about the announcements, the discussions, the syllabus, the files, and the homework.
Could we look at homework one more time?
Yeah, what's your question about homework?
We moved through it a little fast, so I just kind of.
Yeah, so the homework problems are going to be in this
there
section where you open and it'll come up into a new link or a new page.
Yeah, and then so 8 questions, and then if you go down, well, you have to go to the next section, right, to get to the.
Yeah, so here are the questions, or you can just click on continue assignment.
Okay, and so we could either click on those individually, or when you click continue assignment, it showed like question 1, and then just when you click next, it's going on to all the next ones down this list.
It'll just go in order. But if you want to jump to a specific one, you can just grab question 8. You can do the questions in any order you want. And
as soon as you submit it, it's saved and everything.
Yeah, once you hit submit answer, then that problem is done.
Okay, I got it. Thank you.
So once we get this one is 24 feet, then we've done that one. This one is correct and saved. So even if we exit out of here, it remembers that we did this problem.
Awesome.
And since there's no time limit, so if you want to do like a couple of problems, then you get tired of it, and you're like, oh, I'm going to come back to this later, then you can just leave and then come back to it later. There's no time limit. You could even leave the whole thing logged in. It'll make it look like you took 8 hours to do your homework, but when I see that, I just kind of assume it's like, oh, someone fell asleep halfway through the assignment and then came back. So
you're saying go at it at those questions. When we get stuck, then kind of turn to that math textbook and try to figure something out.
Because in the textbook, there's going to be some example that probably looks very similar to what you're trying to do. So start by doing the problems. Maybe you could sort out what you need to do, and then go back to the book if you get stuck. Now, keep in mind, this is if you get stuck, not if you get the question wrong. Because if you get stuck and you happen to guess really well, you still got stuck on that problem. I don't care that you got the right answer, you still got stuck. You just guessed really well. So that should still make a note for you to say, I need to look at this concept in the book. and I need to learn about that. Any questions? Comments? Deep thoughts? Rad. Let's switch over to the board. All right, I think we've done this part. And let's see. We did this part. So now I guess it's time to actually start doing math stuff. Any questions before we actually start doing math stuff? This is the high-tech method that we're going to use for the board for the classroom. It's just this, this notebook here, and I'm just going to write on it with actual pens, and then I'll just scan this with my phone and post it in Canvas. So a little bit of a low-tech approach, but this is high-tech paper because it's not paper, see? Fancy. All right, let's talk about angles, degrees, and triangles. This is going to correspond to section 1.1 in the book. Now, note that this class meets only on Tuesdays and Thursdays. So we don't have the luxury of just doing one section each day because there's only 34 meetings and there are more than 34 sections that we want to cover. Like I said in my initial, in the syllabus, we need to think about trigonometry like trigonometry book club. So there's some problems I'm going to ask you to do and start working on some problems before we talk about it in class. We don't have time to talk about everything in class before you start doing problems. Besides, you might know some stuff already and you'll be able to figure some stuff out before we go over it, go over the problems in class. And so that's going to always make a stronger impression than if you're just trying to copy the things that I do. So really, I don't want you to have to wait for me to go on to the next set of problems, because there's nothing that stops you from learning math. Actually, I'll just stop the sentence there. There's nothing that's going to stop you from learning math. You might not like it. It might not be your favorite subject, but there's nothing that's going to physically stop you from learning math once you determine that you're going to do it. All right. Let's talk about angles, degrees, and triangles, and that'll get us started on all this work. Everybody ready? All right. So we all know what an angle is, but let's be specific because this is math class and math is a very specific language. So I'm going to draw an angle and then we're going to name some parts of this angle. So I'm just going to draw an angle. An angle is just going to be the gap where two lines meet. So here we have an angle. Now I want to name some parts of this angle. I'm going to call one of the sides of the angle the initial side. And I'm going to call the other side of the angle the terminal side. So we're going to start the angle at the initial side and terminate the angle at the terminal side. So the angle is this piece in here. And I'm going to indicate which direction we're going with an arrow. There's the angle. So the angle is that space between the initial side and the terminal side. One way that we measure angles is with degrees. You should have seen that coming because that's like the next thing. Here's an angle. Next thing on the list is degrees. Degrees are one of the ways that we measure angles. One way to measure an angle is with degrees. So one way to measure an angle is with degrees. And I always start with degrees because we're pretty familiar with how degrees work. If I take an initial side and I go all the way around in a full circle, if I make the initial side and the terminal side the same, and I just go all the way around one time around the circle, how many degrees is that full circle? Go ahead and type your answer in the chat. 360 degrees. I told you there's going to be a lot in this class that you already know. Just be confident that you know stuff. Be confident and guess. So a full circle is 360 degrees. And then we just start dividing it up. This is why I like degrees as well, because 360 is an awesome number. It's divisible by so many things. So if I take an angle and I make the terminal side and I just go the initial side to the terminal side, and I just go halfway around. If I just go halfway around, how many degrees is that? 180 degrees. It's half of 360 degrees. Awesome. Sometimes we call this angle, this 180-degree angle, a straight angle because it's just a line. Try to emphasize that there is a vertex right here. So you can probably guess what's coming next. I had a full circle, then I cut it in half to a half circle. What if I cut my half circle in half again to a quarter circle? How many degrees is this? Awesome. I cut the 180 in half, and we get 90 degrees. What kind of angle? How come I drew a box instead of just a little arrow? What kind of angle are we dealing with? We're dealing with a right angle. A right angle is 90 degrees. I don't know if you ever played World of Warcraft, but apparently orcs cannot make right angles. This is why I couldn't play Horde, because you'd have to go to Orgrimmar, and orcs couldn't make right angles. Their buildings really bothered me. I don't know why the roof just didn't fall down and pancake all the buildings in Orgrimmar. Orcs do not have good architects. Or maybe they're amazing architects because the buildings are still standing. I don't know. Besides, you can't be a dwarf if you play Horde, so there's that. So then in between, we have all the different smaller angles. I just tried to scroll the paper with the mouse wheel. Every once in a while, my age shows in my interactions with computers. No, not boomer, Gen X, definitely Gen X. Way more apathetic. So since we're measuring angles, we know that there are positive numbers and negative numbers. So we have to decide on a positive direction. And we decided that counterclockwise is the positive direction. So counterclockwise is going to be the positive direction. We would measure the angle. What we're going to do eventually is put all these angles on Cartesian coordinates, and we're going to start from the positive x-axis and go towards the first quadrant first. So that's why we picked counterclockwise as positive. We, like I was there. I wasn't there. I was out sick that day. I'm just kidding. This happened a long time ago. So for example, if I go half of a right angle here, this would be a positive 45-degree angle. But if I go counterclockwise, but if I go clockwise through 45 degrees, this would be a negative 45-degree angle. So counterclockwise is a positive angle, clockwise is a negative angle. Any questions? Great. Now, since we've been through algebra, we know that we're not always going to have numbers for our angles. We're going to have variable names for angles. We will usually name angles with lowercase Greek letters. We usually name angles with lowercase Greek letters. So we don't have to learn all of them. We just got to learn some of them. So the common ones that we use are, if you make a 0 and then kind of put a smile through it. So like a South Park Canadian, but without the eyes. That's a theta. A lowercase theta. Buddy. Other important ones are if you make kind of a 0, but a small o, and then put a slash through it. Or sometimes you start drawing an O and then you just kind of keep going all the way around. That will be a phi or a phi, depending on European versus American pronunciation. I've heard it pronounced both ways on both sides of the pond, so I will probably switch between the two. I try to alternate, but not usually successful. Other important ones that we should recognize are alpha. You make alpha by kind of drawing a little fish. And we should also note we use beta a lot. Which is kind of like a capital B, but with a long tail and not kind of like a up and down, a down and up motion. So a beta. And gamma. The way I draw gamma is to take an alpha and turn it 90 degrees. So these are the 5 that we'll use most often. Theta, phi, alpha, beta, gamma. So we're typically going to name angles with lowercase Greek letters. The main reason that we want to do this is that we want to distinguish angles that we are trying to measure and lengths that we are trying to measure. So we'll use our alphabet for length. So X, Y, Z, and so on. A, B, and C. Any questions?
What was that last thing you just said with the X and stuff?
So we'll use the letters that we've been using all through algebra. We're going to use those for lengths. We got to measure angles. We're going to use lowercase Greek letters to name the angles. And then we'll use our letters that we've been using in algebra for angles. Sorry, lengths.
Okay.
So we will usually so X, Y, Z. These are all going to be for length. X, Y, Z, or Z to be international. Fonzie. So we want to make sure that we use a different set of letters for length versus and a different set of letters for angle, so we don't get those two mixed up. That's not universal, it's just kind of convenient for us. Any questions? Comments? Snide remarks? All right. We have some other terminology that we may or may not be familiar with. Let's suppose I have a couple of angles. And those two angles add up to a right angle. So let's see. So let's say this is alpha. And here's an angle beta. So if alpha plus beta is equal to 90 degrees, what kind of angles are alpha and beta? What's the word that we use for this? We had a word for complementary. Alpha and beta are complementary. Angles that add up to 90 degrees are complementary. If I have a couple of angles, let's say here's theta. And phi. So here, theta and phi add up to 180 degrees. So what kind of angles are theta and phi? Supplementary. Awesome. So theta and phi are supplementary angles. Any questions? That's just terminology that we want to get used to. My dog's not a fan of angles. We can pause for a second. We may be getting a delivery. And so he's got to save me from being murdered by the mailman. Apparently there's still someone out there who's got to keep an eye on them. All right, let's move on to start talking about triangles. And we're going to start talking about triangles. A triangle is just a figure with 3 sides, and that'll make 3 angles. So a triangle is a figure with 3 sides and 3 angles. A triangle is a figure with 3 sides and 3 angles. So if I draw a triangle, so we have 3 sides and 3 angles. One of the things that we're going to want to do is play a game called solving triangles. That's where I give you 3 pieces of information about a triangle, and you find the other 3 pieces of information about that triangle. So to help us keep things in order, we're going to use the following naming convention, where if I call this angle down here alpha, if this is angle alpha, then if I stand at angle alpha, I'm touching the 2 sides of alpha, and I can see across from alpha what we'll call the side opposite angle alpha. So I'll say if this is side A, I can say that side A is opposite angle alpha. And so I'll make A correspond to alpha, because they're both the first letter. Then going around, let's say I go up to the top, and I'll say if this is angle beta, then opposite angle beta is side B. So we'll say side B is opposite angle beta. I hear the problem. There's a delivery truck down our streets. The Amazon Prime trucks have a weird backup beeper, and he definitely does not like those backup beepers. Then moving on, so we A and alpha go together, B and beta will go together as opposite pairs, and angle gamma will be opposite side C. So this is the common way that we'll name things. So instead of drawing everything all the time, we just have A and alpha are opposite, B and beta are opposite, and C and gamma are opposite. Any questions on our naming convention? This is going to be the usual way.
What do you mean when you say we do this to avoid drawing it out? Like we're in the picture of the triangle, you're just going to give us either the letters or the signs, just one or the other instead of both, so it's less crowded in the triangle?
Well, instead of, I could say, instead of just drawing the entire triangle, I could just say alpha is 50 degrees, side A is 11 inches, and side B is 17 inches. And so that A and that gives the 11 inches and the 50-degree angle. Those are opposing pairs, and then the 17 is one of the other sides. So rather than drawing a triangle where I have to put 50 in here and 11 over here, and then the 17 down here for B, This is just how we normally deploy the names of things. A is opposite alpha, B is opposite beta, C is opposite gamma. This is where we're just going to refer to this as the usual way to name the parts of a triangle. So that's just the usual way to name the parts of the triangle. So we don't associate theta and phi with particular letters. This is mainly this A and alpha, B and beta, C and gamma thing is going to be for solving triangles. It'll become clear in context when we're using this naming convention. All right, let's talk about some stuff that we know about triangles. One of the big things that we know about triangles is that the sum of the angles in a triangle is 180 degrees. The sum of the angles in any triangle is 180 degrees. So in our triangle that we had before, if I had an angle alpha, and I think at the top was beta. Alpha plus beta plus gamma is 180 degrees. So alpha plus beta plus gamma is 180 degrees. First major thing that we know about triangles, the sum of the angles in a triangle is 180 degrees. That means if we have two of the angles of a triangle, we're just subtraction away from knowing the third angle. So as soon as we know two angles in a triangle, we should subtract and find the third. We want to talk about some particular types of triangles. One of the first one that we're going to do a lot of work with is a right triangle.
So you mean like once you know two sides, like two angles, you total up those angles of each side and subtract them from 180, and it gives you the other side.
Not the other side, the other angle.
The other angle, yeah.
Yeah, this has nothing to do with the sides. This is just the angles doing their angle thing. So if one of the angles in a triangle is a right angle, we call that a right triangle. If one of the angles in a triangle is a right angle, we'll refer to that as a right triangle. Since the sum of the angles in a triangle is 180 degrees, and we got to have 3 of them, we can only have one right angle in a triangle. Because if I take up two 90-degree angles, I've already used up all 180 degrees that were allotted, and we'll have 0 degrees left for the third angle. And in Euclidean geometry, that won't happen. Moreover, the 90-degree angle is going to be the biggest angle because the other two have to add up to 90. Moreover, when we have a right triangle, we have a name for the side opposite the right angle. What's the name for the side opposite the right angle?
Hypotenuse.
The hypotenuse. So the side opposite the right angle is called the hypotenuse. The side opposite the right angle. Notice there's only one right angle, so I could say the right angle. The side opposite the right angle is called the hypotenuse. So if our triangle has a right angle, it's called a right triangle. And so it has a hypotenuse. A non-right triangle, that is, if none of the angles are right angles, then we're dealing with an oblique triangle. So a non-right triangle is an oblique triangle. Back in the day, we were coming up with names for a lot of things, like oblique triangles, hypotenuse. If you're looking at X and Y coordinates, we usually refer to them just as X and Y coordinates now, but one of them is called the ordinate. The other one is called the abscissa. Here's how important it is to know which one is which. I don't know which one is which. I can never remember which one is which, and I've been teaching for over 20 years. That's how often it comes up. Also in a subtraction problem, like if we have A minus B, one of those numbers is called the subtrahend and the other is called the minuend. And I never remember which one is which. But like I said, back in the day, we were coming up with all kinds of names for things, probably because we didn't have PS4s and Xboxes. I'd be concerned where math is today if, back in ancient Greece, someone brought like just a PS4. Actually, I know exactly where we'd be, probably in the same spot. We would just be using the Chinese words for everything. Any questions?
I see a question in the chat from Nick, and now it made me curious. He says,
So
well,
for phi and theta, we don't have like standard letters to be opposite those angles. It's really when we need to cover all three, we'll have alpha, beta, and gamma, and then A, B, and C. That's just going to be our usual way for naming things. Any other questions? So we've had a thing that we know about all triangles. The sum of the angles in any triangle is 180 degrees. Now we'll have a particular thing to remember about right triangles. What's something that we know about right triangles, especially since the right triangles have a hypotenuse? What is the thing that we're going to write about next? Anyone know? What thing am I going to write about with the hypotenuse? Start drawing the right triangle.
Isn't there like some like there's like hypotenuse and there's like the opposite hypotenuse? I don't know. Like
I'm going to
make
write
up.
something about the sides and the legs of a right triangle.
The Pythagorean theorem, something
That's the
like that.
one.
What?
The Pythagorean theorem. This is a theorem that applies to right triangles. So this is called the Pythagorean theorem. Which tells you where our math systems are based. Because the Pythagorean theorem was a very old result when Pythagoras came along. But I imagine Pythagoras was like sitting around and he's like, oh, hey, here, check out this theorem. The sum of the legs in any right triangle is equal to the sum of the squares of the legs of a right triangle. It's equal to the square of the hypotenuse. And his students were like, oh, dude, that is so awesome. Did you come up with that? And Pythagoras was like, oh, you ain't never heard of this? And they're like, oh, no. He's like, oh, yeah, I did. That's called the Pythagorean theorem, named after me, Joe Pythagoras. I don't know. I don't think he had a first name, but it's a much clearer picture in my mind when it's Joe Pythagoras saying, yeah, I came up with that. And so we call it the Pythagorean theorem. Then everybody else showed up in ancient Greece and said, oh, I see you're using that right triangle thing. It's like, oh, yeah, it's called the Pythagorean theorem. And they're like, oh, dude, you named that? And they're like, oh, yeah. And he's like, oh, yeah. And they're like, oh, dude, we should have named that. We've known it for thousands of years. And Pythagoras was like, oh, too late now. It's kind of an original Thomas Edison type of move. Steal some stuff and then name it for yourself. Take credit for other people's work. It's a great tradition in math, taking credit for other people's work. So anyway, the Pythagorean theorem says that the sum of the squares of the legs of a right triangle, the sum of the squares of the legs of a right triangle is equal to the square of the hypotenuse. This is not how we usually talk about the Pythagorean theorem, because we all have algebra on our side. So usually we name the legs of the right triangle as A and B, and we name the hypotenuse C. And we say that A squared plus B squared is equal to C squared. This is because we are equipped with algebra. So usually we'll say A squared plus B squared equals C squared for the Pythagorean theorem, because it's faster than saying the sum of the squares of the legs of a right triangle is equal to the square of the hypotenuse. But it does come with the requirement that C is the hypotenuse. In the translate, I'm going to have to enunciate better, because when it says C is the hypotenuse, so I will have to work on enunciation. Any questions? So here we have a piece of information about the angles of any triangle. And now we have a piece of information about the sides of a right triangle. What we need now is something that will connect the sides of a triangle to the angles of that triangle. So we need something that connects those two pieces. So we have an idea for the angles and something for the sides of a right triangle. Now we need something to relate the sides of a triangle to the angles of the triangle. Sum of the angles is 180 degrees. That is an angle thing. The Pythagorean theorem is a right triangle side thing. The angles, it's all the angles are all alpha, beta, and gamma. And the Pythagorean theorem is the A, the B, and the C. We need something that connects the sides and the angles so that we can see how they are related. So we got an angle idea. And we've got a sides idea. And this is only for right triangles. We need something that connects the sides and the angles. So what we need are trigonometric functions. Trigonometric functions are going to make a relationship between the sides of a right triangle and the angles in that right triangle. So let's draw a generic right triangle. Opposite the right angle is always the hypotenuse. I will abbreviate. Now I'm going to name one of the angles. It doesn't matter which one we pick. I'm going to pick the one on the bottom just because I always seem to pick this one. One of these days I'm going to pick the one up here and I'm going to confuse myself. So I'm going to say if this angle is theta, now I'm going to name the other sides of the triangle by their relationship to theta. So rather than using A, B, C, alpha, beta, and gamma, since I have a right triangle, I can say the hypotenuse is opposite the right angle. And if I have this angle theta, I'm going to name the other legs of the triangle relative to this angle theta. So I'm going to say this vertical leg here is the side opposite theta. This is the side opposite theta. And so this horizontal leg will be the side adjacent to theta. So we got the hypotenuse. And then once we have one of the angles theta, we'll have the side opposite theta and the side adjacent to theta. If I call the other angle, say, phi, then the side adjacent to theta is the side opposite phi. And the side opposite theta will be the side adjacent to phi. So saying opposite or adjacent in the context of opposite, adjacent, and hypotenuse is dependent upon which angle we're talking about. But in a right triangle, we'll have the hypotenuse. We'll designate one of the angles with a name, and we'll have the side opposite that angle and the side adjacent to that angle. And using this scheme, we can identify the trig functions. And this will be the last thing today. Just going to define our trig functions. And I'm going to do this in terms of theta. We're going to say that the sine of theta, the trig functions are sine, cosine, and tangent. There are way more trig functions than just these three, but these are the three big ones. Sine, cosine, and tangent. These are the stars of the show. We'll get up to 6 trig functions, but there are way more than that. But we have calculators now, so we don't really need much more than sine, cosine, and tangent. The abbreviation for sine is SIN, so we'll say sine of theta is the ratio of the side opposite to the hypotenuse. Sine of theta is opposite over hypotenuse. The translation, I get to read the translations, and it says opposite over hypotenuse or over hypotenuse. I'm gonna have to work on my enunciation. So cosine of theta is adjacent over hypotenuse, and the tangent of theta is opposite over adjacent. The cool thing about these trig functions is that they're establishing a relationship between the angle in a right triangle and the sides of the right triangle. The Pythagorean theorem only cares about the sides. The sum of the angles only cares about the angles. Trig functions bridge the gap between angles and the sides in a right triangle. It connects those two, the sides and the angles. And so that's what's really cool about defining these trig functions with these ratios. So your job over the weekend is to buy, oh, not Monday. Well, by Monday would be good, but I won't know until Tuesday. By Tuesday, you'll have to remember that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. I see you there, Mark.
Unmute. Hey, good to see you, Evan.
Good to see you too. So there are a lot of different mnemonic devices for remembering which one is which. My personal favorite is sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. I think this means I'm not very creative. If you put them in order, sine, cosine, and tangent, then it's OH, AH, OA. So you can remember, oh heck, another hour of algebra. That's a popular one. But you have to remember that it goes in the order sine, cosine, and tangent. At least I use the traditional order. Or you could put, just remember the SOHCAH and then TOA. So SOHCAHTOA. And now Zoom's transcription feature is really angry with me. It's like, oh, come on, man. You're not saying real words. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. Next time we meet, we're actually going to do some practice problems working with these. So we're going to want to make sure that we have our calculators at the ready. I recommend the TI-84, but any calculator, any scientific calculator will do. This includes the one that's on your phone. This includes the one that's on your phone, but I have, for example, an iPhone. I don't remember what 496 was. But if you turn your phone sideways, then you'll have access to your trig functions, sine, cosine, and tangent. So your job over the weekend before Tuesday is to learn sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. And get working on the homework problems from chapter 1 about measuring angles. So angles and degrees and triangles. Any questions? Comments?
I do have a question.
Yes.
I'm looking at the modules right now. I just see like we have section 1.1, 1.2, 3, 4, and 5. They're all due on August 30.
Yes.
So
We'll have 2 more classes between now and when the problems are due. So we'll get to the rest of them. So just get started on those problems.
Just for now, just 1.1.
For now, you should get started on definitely 1.1, but you should try to do some of the other problems and see how far you get.
Okay.
So the TI-83 plus is also acceptable. It's the TI-83 plus is just the TI-84 with the older version of the TI-84.
So you recommend getting that versus using our phones?
It's easier to type things on this style of calculator.
Yeah. Which one
when
is
it
that
is
that
on
you use?
The iPhone calculator. You can also use Google. The search bar works as a calculator as well. So, and that one's sitting right in front of you.
What's the calculator that you're using?
I use the text instruments. I use a TI-84 plus CE. This is the one that's rechargeable, has a rechargeable battery, and it has a backlit color display. So that's the one that I use. As far as graphing calculators go, I don't use my calculator for graphing all that much, even though I just showed you one of the graphs that I had on my calculator. Because it's not a very good graphing calculator. The better graphing calculator is Desmos.com. That is the best graphing calculator because it's free and it's just sitting right on your computer. I guess the calculator itself is free. The access to it is, you need a computer, which is kind of expensive. Any other questions? Comments? Slide remarks? Desmos.com. Oops, hang on.
That was a lot of math.
All right, so it only seems like it's a lot to remember because it's a lot to remember, and you have to remember all of it all the time in perfect detail. So I guess it does seem like a lot to remember. But it's only 2 days a week, and now you have Friday, Saturday, Sunday, and Monday. You got 4 days to kind of recover and get started on homework, and then we'll solve some triangles on Tuesday. Any other questions? All right. Sorry I didn't get to actually meet everybody. I mean, we're all kind of in the same computer space. So it's really weird on after the first day saying nice to meet you all. So because did we really meet or did we not? You can't even confirm or deny that I'm an actual human being. I might just be a simulation. Who knows? But given the technicalities, nice to meet you all. Welcome to trigonometry. I look forward to working with you on trigonometry. I look forward to learning about trigonometry with you. It'll be fun for me. I don't know about you, but it'll be fun for me. So I hope it's fun for you too. All right, at least I hope it's tolerable for you. Doesn't have to be a laugh a minute or anything like that. All right, that's going to do it for today. Everybody have a good weekend. I'll see you on Tuesday, and thanks for playing.
Thank you.
Thank you.
Thank you.
Uh,